Okay, so today we are going to be doing dimensional analysis. What are the dimensional analysis and how do we do dimensional analysis? The very basics. First, we look at the three basic dimensions: length, mass, and time. These are the three basic dimensions. We know the unit for the length, the SI unit for the length is meter. For mass, the SI unit is kilogram. For time, the SI unit is second. When we discuss the dimensional analysis, we need to actually label it in the form of the word in a dimension. So the length is labeled as L with a square bracket. Mass with an uppercase M, not the lowercase, uppercase M. And time with an uppercase T. Now, if we want to find the dimension of any derived unit, there are the basic units and then there are derived units. For example, there's an acceleration. Acceleration has a formula: change in velocity, delta V, over the time taken. If I want to find the dimension of that one, I need to go back to the SI unit, change in velocity. What's the unit for the change in velocity? Meter per second, isn't it? Meter per second, that's a unit. Yeah. For the time, the unit is again second, 1 over s. Or you can straight away write down unit of acceleration is meter per second square. Now first we get the units, meter per second square. Once we got meter per second square, we need to convert into dimensions. Meter is the unit for length. And when we say length, length is L over second is time, so T square. When we write dimension, we write in one line. We do not write as a fraction. So you must have done the indices, and you know, according to the rule of indices, I can do this L, and obviously I need to put this bit. And then you got T, and that will become T minus T. So if up to you, you want to write it outside the bracket like that, or you can write inside the bracket. I prefer it outside the bracket, the minus 2. So these are the dimension for acceleration. Now, if we do another one where we're trying to find out the dimension of something else. Let's say I want to find the dimension of the force. Now this time I want to find the dimension of force. Whenever you want to find the dimension of something, first start with the formula. What's the formula of the force? F equals to ma. So always start with the formula. Yeah. Now you don't need to go back into details for the A, yeah, because we already know what A is, but we can look at the units for the A. Then you could, after the formula, you convert the formula into units. I know force is Newton, but Newton doesn't help me a lot. MA is going to help me. M is kilogram. The units for the M is kilogram. So I'm just going to write down kilogram. Unit for the acceleration is meter per second square. Yeah, I can do that. Once I write down the units, I will convert the units into dimensions. Kilogram is m. This m small one is a length, meter. So do not confuse that one with a big M. So that's the length over the time. And time is square. If that doesn't help, well, we like in one line, not like as a fraction. So I can write it down m l t minus 2. So these are the dimensions of the force. Remember, whenever we write the dimension, we always write MLT. It's not TLM. MLT is a standard notation. Yeah. Obviously, in some cases, there is no M, so don't worry. M should be first, then the L, then the T. Yeah. So always in that specific order. Always in one line. Always in a square bracket. Yeah. In some literature, you will see it's not in square bracket, it's in different bracket, but the standard notation is in square brackets. Okay, now what I like to do is find the dimensions in MLT. Make sure you write that MLT in the square bracket in a proper order. For dimensions of pressure, density, ignore the term line, just density, surface density, frequency, angular velocity, angular acceleration, and rate of loss of mass. Yep. They have actually given you kind of the formula here, so you can use that one as an help and try doing that one. Try with the pressure first and then just move on. Okay, let's see if you want to find out the dimension of the pressure. First, you need to look into the formula. The formula is actually given here, force per unit area. So pressure equals force per unit area. We have already found the dimension of the force, but let's assume we don't know the dimension of the force. So what we do is we start with the basic units of the force. If I write the unit of the force, Newton, that doesn't help me at all. So what I'm going to do is I will write the formula for the force. The formula for the force is ma. We know the formula is ma. And the area, I know the unit for the area. A standard SI unit for the area is meter square. Now, so that's going to be length times length, isn't it? So the formula for the area is length times the length. Yeah. The reason I didn't put meter square is because then some of us can think the top m and the bottom m, they are same and they will cancel it out. So now I'm just going to put the units. The unit of this m is the mass, is kilogram. The unit of acceleration is meter per second square. Yeah, meter, I can write it that way. And then this is length times length. The unit for length times length is meter square. Yeah, meter square. The dot here mean multiply. Now what I can do is I need to actually write in MLT form. But before I can do that one, I see if I can simplify some things. Kilogram as it is, there is an m and there is an m square. So what I can do, I can simply cross this and that just becomes a m. So I have got kilogram over m, which is the length, meters. Yeah, that's not the mass now. And the second is second square. Now I put the dimensions. Kilogram is mass, so that's going to be m. Yeah, uppercase m, because we know the dimensions. That's the length. And that's the time. Second is time. It's not an I, it's a T. But we don't like to write that way. The way we like to write is MLT. So M is going to be here. L is going to be here. But that L, when it comes up, according to the law of indices, it becomes a -1. And T is going to be -2. That's the dimension for the pressure. M, L -1, T -2. Now we have angular velocity. We only know about three things, MLT. Yeah, there's another thing, BLT. Heard of BLT? So we're not doing BLT, it's just MLT is the one that we know. So MLT is the one we know. Now we stuck with an angle. But we only deal with MLT. So angular velocity has symbol, which is this. Yeah, it's called omega. Angular velocity is known as change in angle, changes in angle over time taken. That's the formula for the angular velocity. I do not have the units for the change in angle as an SI unit. I know there's a degree and I know there's a radian. Yeah. So let's go with what we know. The unit for that one is radian. Yeah. We deal in radians. Yeah. You can write on RAD or you can write full. And the unit for that one is second. Yeah. I'm writing full. You don't have to. I don't know what to do with radian. I'm stuck. But I know the second is T. If I don't know that one, that's just a 1. So the unit for the dimension for the angular velocity is going to be T. Bring the T from the denominator to the numerator. That becomes T minus 1. These are the dimensions. Yeah.